So guys, let's welcome to our channel Just Genius. In the last tutorials, we have completed asymptotic notations. In this video, we will start how to analyze an algorithm using three cases. What are those three cases means? Best case, worst case and average case. Based on these three cases, we can analyze an algorithm. Three cases exist to analyze an algorithm based on three notations of time complexity. Okay. So by these three cases, we can analyze an algorithm based on three notations. What are these three notations? Big O, big omega and theta notation, okay, of time complexity. So when you look into this worst case, because why I am going to always teaching the worst case primarily means worst case is mostly used case, because when you know the worst condition, you can improve it to some better, okay. Like that only in the case of time complexity, when we calculate the worst case time complexity, we can improve it some. No, that's why we are taking always the worst case, that always the time complexity is calculated in the worst case. It should calculate in upper bound. You can study this point. Calculates the upper bound on running time. It considers a maximum number of operations to be executed. Okay. So I'm taking an example of the linear search here. So linear search. So even though I will discuss the binary search, only the best case and worst case cases. Okay. First, let us look into linear search. So this is a linear search. So if I want to find an element, so our target element is 95. If I want to find the element out of this array, means whether the 95 is exist or not, I have to check it. So it searches from 1 to till the end of the array, so till the length. So it searches till the length of this array. So if 95 is present, it shows it prints present, otherwise not present. So here 95 is not present, it prints not present. So it searches, compares it with all length 1 to 1, means it searches each and every element whether the 95 is present till the length of our array, means so the worst case time complexity becomes big O of n. Here n is nothing but length of our array, length of array, means till the last we are going to search. That's why the worst case is taken here, big O of n. Otherwise, if you want to search, our target is to suppose our target is to find 2. 2 is at the last, till it searches the last and finds 2 and prints 2 is present in the array. Okay, it also takes big O of n only, because it searches till the last, till the length of the array. The worst case time complexity is taken as big O of n in the case of linear search. So when you look into the average case complexity in case of linear search, so when we come to this average case, you may be knowing that average equal to all possible time by number of cases, all possible cases time by number of cases, means it taken here same in the same manner, it is calculated like this only. So this is all possible time, this is nothing but number of cases. Then we got that our time complexity is big O of n. Okay, so when we look into this, take all possible inputs and calculate computing the time for all the inputs. Sum all the calculated value and divide the sum by the total number of inputs. So we have divided the sum, that is nothing but total number of inputs is nothing but n plus 1 here. In case of linear search, so you can take any elements here. Our target is to find 95. Okay, all uniformly distributed. So when you study this point, you may be understanding how average case analysis works. So you don't use mainly average case, so it is given rarely used case. Okay, you remember how to calculate the worst case time complexity, because it is mostly used. Okay, so next, when we look into this best case, this is very rarely used, so no need to discuss about the best case because it is very rarely used, but we will see. So when you look into this linear search, best case is nothing but our target is to find 14. So 14 is present in the first. So if the element is present in the first, it is easy to us to calculate best case time complexity. So our time complexity becomes big O of 1. So best case time complexity is nothing but big O of constant. Okay, big O of constant, so nothing but big O of 1. You have to remember big O of 1 is the best case time complexity, just remember this. Okay, This is the best, worst and average case. How to calculate in the case of linear search. So I will write in this one. I will show also binary search best case, worst case and average case. Okay. You look into here, we have calculated for linear search. In the case of linear search, so worst case time complexity, worst case is big O of n, best case is big O of 1, because when we want to find element at the first index, it already present in the first, it takes less time than to find element at the last. It takes less time if the element is present at the index first, at the index number 0. Also average case is nothing but big O of n. In the case of linear search, when we talk about the binary search, so I will discuss this binary search here. So when we discuss the linear search and binary search in further videos, we will discuss full clarity about the linear search and binary search. But here, just to remember the time complexity, means what is the best case time complexity in binary search and linear search, we have to just remember it. Okay, means in case of binary search, suppose a tree present like this: 20, 10, 25, 2, 12, binary tree. This is called binary tree. 23, 28. Okay, suppose if you want to find your key element is to find 20 is present here, it takes less time, that is nothing but best case. So here also best case equal to big O of 1. Okay, I told you here worst case, this is important. Worst case equal to log n. Wait, I will show you. I will write clearly. Okay, worst case equal to big O of log n. Because why did I write log n? Because in the linear search I have taken length of the array as an worst case. Means if the length of an array equal to n, then it is nothing but big O of n. Okay, so similarly like that, it is in binary search, it is came to that height of the tree comes, so it becomes big O of log n. Here height of the tree is nothing but, when you calculate the height, it becomes log n. The total time complexity in the worst case is nothing but big O of log n. When we discuss about the binary search in further videos, we will discuss each and every point clearly. Just remember the best case in binary search is big O of 1, and worst case in binary search is big O of log n. Okay, with this we have completed how to analyze an algorithm. Thank you.